Hello and welcome to my video, lesson 1.6, Patterns/Equations to Graphs. So if you look at this first question, we see we have an input-output machine, first timesing by 2, then minusing 1. So if we choose random inputs, we could have dots anywhere. But if we choose some inputs that are in a row, it'll maybe make things a little bit more clear. So let's choose some of the simple inputs. Let's choose 1, 2, 3, 4. Then you just need to take these inputs, go through the machine, get the output. So 1 times 2 minus 1. So let's do the work over here. We can erase it after. 1 times 2 minus 1 gives us our output. Well, 1 times 2 is 2, minus 1, so 2 minus 1 is 1. So our output is 1. Okay, if we do the next one, well, maybe we can go 1. Maybe we can do this in a different color. 2 times 2 minus 1, 2 times 2 is 4, minus 1 equals 3. So we have 1, 3. Okay, now let's try the next one. 3 times 2 minus 1. 3 times 2 is 6. Minus 1 is 5. Next one. 4 times 2 minus 1. 4 times 2 is 8. Minus 1 equals 7. So now we have a set of inputs and outputs, and it's identical to the last topic. So I'm just going to quickly put these into our graph. Remembering, of course, that this is y, this is x. So first one is 1, 1. Second one is 2, 3. Third one is 3, 5. Fourth one is 4, 7. And you can quickly, somewhat quickly, also have a line if you'd like it. And you could continue the line further if you'd like as well. So this is our line, and those are our points. So you can see that those will continue on forever. And that makes sense because our input-output could be any input at all. So this ordered pair here, this is the really cool part. This is where it gets really exciting. So this ordered pair, according to our graph, is 5, right? 5, 9. Okay, so 5, 9. That's our ordered pair. Now, using the input-output, we have 5 times by 2 minus 1. Okay, 5 times 2 is 10. Minus 1 is 9. Wow, look at that. 5 to 9. 5 and 9. So our graph can do the input-output machine for us. It's an amazing thing. It's really the whole purpose of graphing. So really, quite an amazing feat. Okay, so that was if we get an input-output machine. What if we get an equation? Well, it's the same. It's the same thing. So here our equation is. Oh, sometimes I use a star. I'll fix that. I don't like using the star. There you go. So anyways, that dot there, or if it was a star, it means times. So 3 times by, and we have to just pick a bunch of inputs. So let's pick some inputs. Like I said, I like to choose 1, 2, 3, 4. You can choose other ones if you'd like, but remember it has to stay on the graph, so that's why I choose 1, 2, 3, 4. They're more likely to stay on the graph. So 3 times 1 plus 1 equals y. Okay, so 3 times 1 is 3, plus 1 equals 4. So y is 4 in this case. Okay, now let's keep going, and I'll just do it all in one color. So 3 times 2 plus 1 equals y. So 3 times 2 is 6, plus 1 is 7. 3 times 3 plus 1 equals y. 3 times 3 is 9, plus 1 equals 10. And last but not least, 4 times 3, or 3 times 4, whatever. We'll just keep it the same so we don't make a mistake. 3 times 4 plus 1 equals y. 3 times 4 is 12, plus 1 equals 13. So just so we're all clear, this is from the input, this is from the input, this is from the input. 1, 2, 3, 4. And our outputs are 4, 7, 10, 13. 10, 13. Okay, so let's just move all that to the side here. Wouldn't you be happy to do that on your regular paper? Okay, so we have input and output. What color did we use there? We used, okay, I'm going to use red as our dots. So 1 and 4, so 1 and 4, so just going like this, 1 and 4 to get to here. 2 and 7 gets me right here. 3 and 10 gets me to right here. Okay, and the other one's actually off my chart, so I'm not even going to put it on here. Sometimes that might happen, especially if you're going this way around. So now you can put your thingy thing in, your ruler. Very specific thingy thing, hey? Okay, my ruler's on here. Now I can draw the line. And you can see that our line has found us another point, which is pretty cool. So that point would be 0, 1. Okay, so we have found some interesting things here, but I'm going to go on and I'm going to say something even more amazing. Our change and our base case are really important. They're related to our graph, okay? So I'm going to just show you here, this, because it's being multiplied by the x, this was our change, right? And blue, this one here, because it's being added, is our base case, right? This is going back 2 topics, I believe, to 1.4. Yeah, 1.4. So with that in mind, change and base case, if we use those, we can find some amazing things. Base case is what we call the y-intercept. Now I'm gonna blow your minds here a little bit. Maybe I could change. Hold on, I'm gonna change this to. Oh, I should have done the different color. This should be purple and this should be blue, just so they can correspond to what's on the graph already. Base case, because you can see that our base case is where it has a 0 for x. Well, if it has a 0 for x, it's gonna be on this big old line here, right? That is the y-axis. So we actually call this the y-intercept. So I'm gonna label this here, base case. This is beyond grade 6, but this is very interesting. Y-intercept. And I'm going to label something really important here as the change. The change going up, like this. This is the change of 3. Up, 1, 2, 3, change of 3. Up, 1, 2, 3, a change of 3. Okay, this is the change in output, which is what we've normally been calling the change. I do want to point out there is a change in the input, it's a change of 1. Change of 1, change of 1. That is this change. For all of you people that really need to learn this, or really want to learn ahead of time, that's what this is. It's actually an amazing thing, and we call this 3 over 1. We call this whole thing the slope. Alright. Amazing stuff, really important, but again, this is a little bit beyond grade 6. All you really have to know how to do is this stuff at the top, which is just take an input-output machine, put it into a table, or take an equation, put it into a table, and then plot the points. So I hope this video helps you understand patterns / equations and changing those into graphs. Good luck!